Okay, so we've been working our way up to graphing trait functions, and today we actually get to graph them. So here's your title. And then we have amplitude, a definition for that. So that's half the distance between the maximum and the minimum. So basically from the middle line, how high it goes up and how high it goes below. And then you'll need to write down some of this stuff as well. I'm going to hit pause and highlight it. So those are the parts that you're going to want to copy down. So each graph has 5 key points. For sine, it starts at 0, 0, goes up to the maximum. By 180, it's back at the 0 line again. At 270, it's down to its minimum, and 360 completes one cycle of it. So its period is 360 degrees, and its amplitude is 1. It goes up to 1 and down to 1. Cosine starts at its maximum. Then it hits its 90 degrees, it hits the 0 line. At 180, it goes to its lowest point. 270, it's back at 0. And 360, it goes up to the maximum point. So again, it also has an amplitude of 1, and its period is 360 degrees. So the graphs also, though, can be transformed down below here with A and B. So A and B. A is going to be our amplitude, and the period is 360 divided by B. And notice each one of them is in absolute value bars, meaning that you don't worry about the negative sign on them. You just divide it by whatever the number is, not the sign of it. All right, here's some more to put in there. Frequency is how many cycles there are in a given amount of time. All right, and then tangent. Again, I'm going to need to highlight a few things here. Tangent is an interesting looking graph. It has asymptotes. We've talked about those before. So it has lines that it approaches, but it never touches. I'm going to hit pause so I can highlight those. So tangent, it doesn't necessarily have 5 key points, but what it does have is it starts at 0, and it's going to swoop up. It's going to have an asymptote at 90 degrees, and then it's going to end at 180. So from the asymptote, it's going to swoop back up again. So you want to think about this part as one cycle of tangent. Not one of the curves, but from 0 to 180, that's really what tangent looks like. And then we'll just be doing multiple representations of that. Okay, then we have cosecant, secant, and cotangent. So the way we do those graphs, if you look at the red part there, that is the graph of sine. And so anytime that sine touches the x-axis, we have to draw in asymptotes. That's these pink lines here that I'm covering up with black. And then what you do is you flip the graphs over. Okay, same thing with secant. You're going to graph cosine. That's the red line. Then you draw on the pink dotted lines wherever cosine touches the x-axis, and then you flip it over. All right, tangent is a little crazy looking. So if you notice with tangent, tangent had asymptotes at 90 degrees, and then, but it got shifted over 90 degrees to 180. So it shifted it over, it flips the graph upside down. So you take a tangent graph, you slide it over, and you flip it upside down. Okay, so here's the equation. So B represents the number of cycles in 360 degrees, and A is our amplitude. Kind of talked about that a little bit already, but it's good to summarize it again. Okay, let's start with this one. So sine 1/3 theta. So first of all, we need to think about what is our amplitude, and then what is our period. All right, amplitude is a value. Remember, we think about it as a sine of b theta. So there's no number in front of sine, and so that just means that there's a 1 there. All right, what is our period? Our period for sine is 360 divided by the number in front of theta, which is b, divided by 1/3. Okay, so dividing by 1/3 is multiplying by the reciprocal. 360 times 3/1, which is 1080. So it takes 1080 degrees before it finishes a cycle. So we probably do not want to start this going by too small of increments. Let's say that we go up by 360 degrees. Notice that there's some spaces if you have this paper. So 360, 720, 1080. What would come next? That would be 1440. All right, let's go by ones. 1, 2, 3. Oh, those are all negatives, sorry. Okay, sine starts at 0, and it will end at 0 again at the end of its period. So at 1080, it'll end at 0. So what is halfway in between there? Right there is where it's going to meet halfway. And now halfway in between each of those, it's kind of like finding our quartiles. Right there, it's going to be at its maximum. And halfway between the other ones, it's going to be at its minimum. So we graph this by hitting these 5 key points. Okay, so then we can think by about right there, it's going to get another maximum. And then it'll be coming back down again. So there's our graph. I think, okay, the next one then, oh, this is a clicker question, so you could try that on your left page and then check it in class. The next one, sine of 3 theta. Well, what's our amplitude? Number in front of sine. There is no number, so it's just 1. And then the period is 360 divided by the number there, so divided by 3. So that's going to be 120. This time the graph needs to finish by 120. So where would 120 be? Well, if we've got this labeled at 90 right here, that means each one of these is 30. So that's got to be 120 degrees right there. So it starts at 0, ends at 120, because that's what sine does. Sine always starts here, goes up and down, and then back up again. Okay, where's its halfway point? Halfway point is going to be at 60. And then the lower half is going to be reaching its maximum. Its upper half is going to reach its minimum. So we can just go through like this. And that's what our graph looks like. All right, how about this one? What's our amplitude? Well, that's the number in front of cosine, so that's 1/2. Our period is 360 divided by the number in front of theta. Well, there's no number there, so that means it's a 1. So 360 degrees. All right, so that means we start, cosine starts at its maximum, which is 1/2, so right here. And it ends at its maximum, which would be right here at 360. Halfway through is when it's at its minimum, so halfway between 0 and 360 is 180. And halfway between each of those is when it touches 0. So we go through and graph it like this. Because cosine always has that U shape to it. All right, so what is the period for this function? Humans can hear the sound with a frequency of 40 Hertz. Find the period of the function that models sound waves. So when we're talking about sound, it's how many times does it vibrate per second. So it can go up and down 40 times in 1 second. So to figure that out, its typical length is 1. So you would take 1 divided by how fast it's going this time. So it's just 1 out of 40. That's our frequency. So what would this graph look like? Well, if we tried to do it by 1 second, if we try to put 1 second on here, we're going to have to get up and down 40 times. And we're going to be going like this and try to get 40 times in there. So I don't know that I can draw it that good. So what if we did a half a second? How many would we have to do? We'd have to have 20. Okay, what about a fourth of a second? That'd be 10. Okay, we're getting a little bit more reasonable. What about an eighth of a second? That might be the most reasonable. That one we're going to have 5 in there. So let's go 1/8 of a second. Maybe we want to put that at the end, I think. 1/8 of a second. So we need to have 5. So it starts at 0, and it has to go through 5 full cycles. So it has to touch 5 more times. Let me count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe I should help myself out here and just put it at 10. So this mark right here is 1/8 of a second. That'll help it out. Now each one has to complete a cycle every 2. So it's got to go up. Oh, I did that wrong. Up and down and back up again by that time it gets to that dot. And so it would, oop, I missed there. It would just keep on going forever. But that's what the graph of that one looks like. All right, let's try tangent one. Well, it looks like I had them drawn here, but that's probably not the best graph for that one. So tangent, the amplitude is the same. It's the number in front, which is 1. And then we can figure out the period. Now be careful. Sine and cosine, the period is 360. Tangent, the period is 180. So if we take 180 divided by half, which is multiplying by the reciprocal, so the period is 360 degrees. So here is my period for tangent. Now remember, tangent looks like this. It swoops up, asymptote halfway through, swoops back up again. So it's going to start at 0, 0, and 360, and halfway through it's going to have a dotted line, an asymptote. Oh, that didn't get so dotted. So it's going to swoop up and swoop up. Okay? Next time it's got to have a dotted line halfway through, swoop up, swoop up. Let's go backwards. So I'd have a dotted line right here. I'm going to go backwards, swoop down, and here it's going to swoop up and off to the side. There's our graph of tangent. How about cosecant? So cosecant is the reciprocal of sine, so we have to do sine first. Amplitude is 3. Period, 360 divided by the number in front of it. There isn't anything, so it's just 360. Okay, so let's just draw sine as a dotted line. So it has to start here, end here. Middle, it's at 180. Halfway between 0 and 180. Halfway between 0 and 180 is our amplitude, which goes up to 3, then down to -3. Okay, and let's do that again over here. Okay, so we're just going to lightly draw in a dotted line sine graph. Because this is just our guide. Now, everywhere that it touched the x-axis, we draw in an asymptote. And now we flip the graph over. So this one swoops right here. It touches at that 3, 3 point. Or not the 3, 3 point, but at the maximum of 3, minimum of -3. But it does not go beyond its asymptotes. So now if you'd like to clean up this graph a little bit, you can remove all of our sine graphs. It's needed as a guide, but it does kind of clutter it up a bit. So that is what cosecant looks like. If you have a pen, don't worry about it. You don't need to erase it. All right, that's the end of the lesson. Write your questions and your summaries.